this lesson, we are going to go over some of the rules of exponents. In particular, we want to multiply and divide powers. Essentially, when you had your warm-up, we want to be able to do things like this. We want to be able to divide exponents or divide powers, and we want to multiply powers as well. And we can do them with the expanded format, or we can search for shortcuts. Well, this is one of the significant rules that we need to remember. If you want to multiply powers, the rule is just to add their exponents. We saw the expanded format here, but then we saw that we could just take 7 plus 6 and equal 13. That's what we're doing here. With an exponent of 3 and an exponent of 4, using the same base, an exponent of 3 and an exponent of 2, all we have to do is add the exponents. 3 plus 2 equals 5. And we're done. So, applying this product of powers property, 4 to the 7th times 4 to the 11th, what do you do with the exponents? Add them. 7 plus 11 equals 18. We're done. Moving on, where we start having some variables. 2 times 7. We'll just do the multiplication with the multiplication. 2 times 7. Numbers with numbers. And variables go with variables. X squared times x6. Variables go with variables. Well, since we're multiplying here in the red, we'll use our shortcut. X squared times x6. What do you do with the exponents? Add them. And so 2 plus 6 would equal 8. And we could just do our regular multiplication. 2 times 7 equals 14. X to the 8. And we're done. Without the guidelines, without all the tools, what we're seeing here, we can do this with a lot less writing simply by recognizing here. Numbers get multiplied with numbers. 2 times 7 equals 14. Variables get multiplied with variables. But they have the shortcut of adding the exponents. 2 plus 6 equals 8. We're done. The notes part just writes it out with every single step, showing you every single piece in the thought process, but that creates a lot more with the writing than you actually need. So let's write these with exponents. 2 to the 5th times 2 to the 12th would equal 2 to what exponent? 5 plus 12 equals 17. We're done. Having a bunch of repeated multiplications, 0.4, 0.4, 0.4. Let's get the exponent. 6 plus 2 plus 3. We're done. And it works just as well for variables. X times x, and we just need the exponent. 6 plus 13, we're done. B times b times b, just add the exponents. 2 plus 4 plus the unwritten 1. If we don't see an exponent written, we understood it's a 1. So 2 plus 4 plus 1 is 7. We're done. Really quick, really straightforward. When you multiply things that have the same base, all you have to do is add the exponents. That's the product of powers property. There is also a quotient of powers property. In particular, it's like the one that we did here. If you are going to divide out exponents, we saw that they can create these pairs, and the end result is a shortcut for subtraction. If you are dividing out powers, the shortcut is to subtract. So here, 5 to the 7th divided by 5 to the 4th. 7 subtract 4, I want a better color there, equals 3. We're done. Similarly, 0 to the 6th, 0.6 to the 8th power, divided by 0.6 to the 3rd power. What do you do with the exponents? Subtract them. 8 minus 3 is 5. We're done. Do the same thing. X to the 7th, x to the 3rd. Since we're dividing, 7 minus 3, which gives us 4. When we simplify out that fraction, dividing out by 3, we wind up with x to the 4th over 4. And again, I'd like to show you what this stuff looks like without all the structure and the guidelines, without every little step. There are two components to this problem. We have the number part and the variable part. If we are looking at only the number portion, that's a fraction that can be simplified. What is 3 over 12 simplified to? Well, if we divide those out by 3, we wind up with 1/4. So still simplify fractions the way you've always done. For here, though, working with the variables, we know our shortcut is to subtract the exponents. 7 minus 3 is 4. And so we wind up with 1 times x to the 4th over 4. But when you multiply by 1, it doesn't do anything, so here's our answer, x to the 4th over 4. That's all the writing that's needed. You can get the answers directly. So what about these? 5 to the 9th over 5 squared. 9 minus 2. Done. 1.4 to the 7th over 1.4 to the 4th. 7 subtract 4, 3. When we have monomials, 4 divided by 2, that's 2. 13 subtract 9. Hang on a second, I gotta backtrack. I had the wrong number there. It's not 4 over 2, it's 4 over 24. 4 over 24 would simplify down to 1/6. Because we'd have to divide both the top and the bottom, divide our numerator and denominator by 4. Right, so we've got that part, and then we need the variable portion. 13 subtract 9. So we've got the number portion, we've got the variable portion, and those two things can be written together, x to the 4th over 6. And we're finished. Take the same process for number 8. The number portion, 14 over 6. What does 14 over 6 simplify down to? Well, what can you divide by? divide by 2, divide by 2. That would give us 7 over 3 for the number part. And that doesn't simplify any further. We could write it as a mixed number, 2 1/3, but it's actually easier for us when we recombine things if we leave it as a mixed number. I'll show you why when we finish the problem, and just see how it looks better. Coming to the variable part, x to the 16th divided by x to the 11th. 16 subtract 11 is 5. And so if we put those two together, we've got 7x to the 5th over 3. And we're done. A chance you said 2 1/3. We could write 7/3 as 2 1/3, which is absolutely correct. And if we wanted to take that approach, we'd have had 2 1/3 times x to the 5th, which would have given us 2 1/3 x to the 5th. Here's the danger with that. When we write it out this way, it looks like this is saying 2 times 1/3 times x to the 5th, which would actually be 2/3, not 7/3. And so there's a risk that way. To avoid this potential confusion, you could have wrapped this up with parentheses and written it out that way to avoid the possible confusion. But then when you start putting parentheses in, and it looks a little bit more complex, most people would prefer the information in the blue as opposed to the information in the red, simply because it's, well, in my opinion, there it just looks cleaner. It looks nicer, it looks easier. And there's not a potential confusion with being wrong. All right, now what if we start combining them? If we have multiplication mixed with division of powers, that won't be a problem. We'll just have a mixture of adding and subtracting the exponents. For here, we would have to say, we've got this multiplication on the top, so we have to work with the exponents. That will be 3 plus 4. 3 plus 4 gives us 7. From here, we've got m to the 7th over m squared. That's when we subtract. 7 subtract 2 would give us 5. Lastly, we would have to simplify our fraction, 4 over 12. So if we divide it out by 4, that would give us 1 over 6. I'm sorry, 1 over 3. So m to the 5th over 3. And we're done. Once again, all of this stuff here is providing each and every single little step. We have the ability to put these things together and combine steps. Another way that we could have done this, we could have looked at it and said, just focus on the numbers without the variables. 4 over 12. Simplify that fraction. That would have given us 1/3. After that, we could have looked at each of the variable parts. Multiplication, which we know we'll have to have adding exponents, and division, where we know we will have to subtract exponents. We could put those all in one step. 3 plus the 4, subtract the 2. So what's 3 plus 4 minus 2? That's 5. So our exponent is 5. That's our answer. 1/3 times m to the 5th. But because we like the structure better, we could simply write this as m to the 5th over 3, and it looks a little bit simpler. Same answer, just written in a slightly different way. And a lot less writing on the right-hand side than we did on the left. Alright, so let's finish these two out. Look at our variables, or the numbers. What does 6 over 15 simplify down to? Well, if we divide out by 3, that gives us 2 over 5. When we look at the variables, m to the 5th, and I wanted this in red, m to the 5th times m divided by n cubed. Here we have the unwritten exponent of 1. So we need to take 5 plus 1, subtract 3, which is overall 3. This is our answer, 2/5 times m cubed. Because we like the format, we can also write this as 2m cubed over 5. Both answers are correct. It's just a matter of which way you prefer to write it out. My own personal preference, I like this one. It fits better into polynomials, and polynomials are a piece that you will do with your algebra class, so given that I'm more comfortable with polynomials, I just like the look of the top one better. It's been my experience, though, that most students in pre-algebra prefer the bottom one. They're both correct, so it doesn't really matter which one you do. Okay, looking at number 10. 10 over 5. 10 divided by 5 equals 2. Taking the variable portion, n squared times n to the 6th divided by n cubed. That would give us 2 plus 6, which is 8, minus 3, which equals 5. And right there, we're already done. We don't need to rewrite it. 2m to the 5th. And that's actually it for this video. All we needed to do, all our objective was, learn how to use the product of powers property, just add the exponents, and the quotient of powers property, just subtract the exponents. It's about knowing when to add and subtract exponents when you multiply powers with the same base.